Hi everyone, welcome back. Mrs. Lokes here. Let's get at this. You may not have these notes. If you don't, you can email me and I will send them to you, but I wouldn't worry about it. There's not actually a lot on the paper, and you can just do this on your own paper and then get the note package from me Monday. Okay, we're going to do some work now with algebra tiles, so I would just like to refresh your memory a bit. Need a pen. Okay, so a rectangle like this is an X tile, or a negative, or a Y or a W or whatever letter you want to call it. One that's filled in is a negative X. One that's a big square like this, that's an X squared, or a negative X squared if it's filled in. And then the other one we have is a little one like this. It's a tiny square or a filled in tiny square, and this is a 1 or a negative 1. Okay, now that is backwards from what you did in grade 9, unfortunately, but this is how the provincial exam does it, so this is how I'm going to do it, just so you're not faced with something new and backwards when you go to write the exam. Okay, so we're going to go to, I need to go to a different document for this, okay, so that I can move my squares around. And what we want to do is take what we have here is we have 8, we have 8x and 4 1s, so we have 8x plus 4, and we want to make this, do a multiplication rectangle with this. So we could do, if we had 12, for example, just working with numbers, we could say 12. I could write that as, do a rectangle like this, that's 1, oh, this doesn't like straight lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I could do, that's 1 times 12, so 12 equals 1 times 12. Okay, or I could do 12 equals 2 times 6. I could do it like this. Okay, those are different ways of showing multiplication of it to create 12. So we want to do the same thing with 8x and 4. So let me show you what you are not allowed to do. You can't do it like this and line these up like this because they don't fit. That is not that this is 4 wide or 5 wide or anything. This is the x length is just some random length because we don't know what x is. So you're not allowed to do this, okay? What you need to do is line them up end to end like this. And we're going to pretend that I'm putting them all in a nice neat little line, but I don't think you want to watch me fiddle around with that. Okay. Do, 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 do. Okay, so if I were to write this as a multiplication statement, this would be this would be 8x plus 4 equals 1 times 8x plus 4. Okay, what I should do here, what I want you to see, is where I got those numbers from. Maybe I'll do this in red. Okay. Oh, this is going to be hard. Okay, this end is 1, and this is, there's an x, there's an x, there's an x, there's an x, doo-doo-dee. And then 1, 2, 3, 4. Okay, oops, that last one didn't stay. Okay, so here's 1, and this side is 8x plus 4. Okay, so this shows that if I multiply 1 times 8x plus 4, I get 8x plus 4. Now I'd like you to copy this down so that you have this on your paper, and then I would like you to play around with drawing it yourself, and try and come up with another multiplication statement that will equal 8x plus 4. Okay? So stop the video and go ahead and do that. There are actually 2, so you see if you can find 2, and I will write them up for you. Okay, this time I'm a little more compact, and you can see that this one is 2 times 1, 2, 3, 4x plus 2. So this time I have 8x plus 4 equals 2 times 4x plus 2. There's one more, so pause the video and go find it. Okay, now we have a nice compact rectangle. Where on this side we have 1, 2, 3, 4, and on the top we have 1, 2x plus 1. So 8x plus 4 equals 4 times 2x plus 1. Okay? So make sure you have that copied down, and I'm going to flip back to the other page of notes right now. When we write a polynomial as a product of factors, we factor the polynomial. This is just some vocabulary that you really need to know. And a polynomial is fully factored when we have factored out the greatest common factor, GUKF, and the polynomial cannot be factored further. So that last one we did, where we got it as 4 times 2x plus 1, that was fully factored. So a comparison between arithmetic and algebra. So in arithmetic, if you multiply factors to form a product, for example, 4 times 7 equals 28. And in algebra, we call that expanding. So we expand we expand an expression to form a product. So for example, 3 times 2 minus 5a equals 6 minus 15a. So they're the same thing, we just have different vocabulary in arithmetic and in algebra. And in arithmetic, we factor a number by writing it as a product of factors. 28 equals 4 times 4 times 7. So these are opposites, right? And in algebra, we factor a polynomial by writing it as a product of factors. So 6 minus 15a equals 3 times, in brackets, 2 minus 5a. These are opposite or inverse processes. Get this into your head. Okay? You need to know this. So, vocab alert. Let's put something down here. Expanding an expression. Oh, I don't think you can read that. Write a product of polynomial factors as a polynomial. What the heck does that mean? That is when you do this here. You're taking polynomial factors and you're multiplying them together to get a single polynomial. And just as a reminder, what is a polynomial? A polynomial is an expression made up of one or more terms. So 6 minus 15a is a polynomial. 2 minus 5a is a polynomial. 3 is technically a polynomial as well. It's just got a single term. Okay? So let's go and factor some polynomials, because that's what this is all about. Vocab alert, a binomial is a polynomial of two terms. Okay, you did learn that last year. So we're going to factor these binomials. So using algebra tiles, we have 3 that look like this, 3 G tiles, which look just like X tiles, and 6 ones. So you need to play around with these until you get them in a rectangle. I'm just going to draw it out for you because I can't show you moving them around. It's too hard to do on the screen here. But I will get you some so you can play with it on your own. We'll have them in class. So on this side we have Okay, so 3g plus 6 equals 3 times g plus 2. I'm hoping you can see that. Okay, second method is to use the greatest common factor. So I'm going to write it, I'm going to do this the way we learned to factor other things. So 3g plus 6. If I write it like this, what goes into both of those? Well, how about a 3? So 3g divided by 3 is g, and 6 divided by 3 is 2 plus 2. So I get the same result. I get 3g plus 6 equals 3 times g plus 2. Now, I also want you to check your answer. Now, up here when we use the algebra tiles, it makes that you can see that it works, right? It filled up the whole rectangle. When we're doing it algebraically, you need to check this. So we're going to expand the factored part. So we're going to do our rainbow lines, and this becomes 3g plus 6, which is right. You need to check it every time because we are, as humans, we're much better at multiplying than we are at dividing. And it's so easy to make a mistake when you're factoring it, and it's so easy to check. So please check every time, please. Okay, now I'll do an example using some d squared tiles. So I have 12 big squares and 8 rods. So I need to figure out how to make that work. I'm going to do, it's going to be a 4, 1. I need to fit them into a rectangle, right? That's the idea here. A nice, tight, as close to square as I can get it rectangle, instead of a long, skinny one, right? So there's my rectangle. And now that I have my rectangle, I need to see what I made it up of. So This is a D. This is a D. This is a D. This is a D. So this is 4 Ds. There's a D. There's a D. There's a D. There's a 1. There's a 1. So that's 3D plus 2. So 8D plus 12D squared equals 4D times 3D plus 2. Okay? And I can check this algebraically with my rainbow lines. So 4D times 3D is 12D squared, and 4D times 2 is 8D, which is what I started with. I just have it written in the other order. So there we go. Now let's do this one using the greatest common factor. So I have 8D plus 12D squared. What goes into that? Looks like 4D. 4D goes into 8D twice, and 4D goes into this 3D times plus. So I get the same thing, which is good. 2 plus 3D equals 8D plus 12D squared. Okay, and of course it doesn't matter whether I write it as 2 plus 3D or 3D plus 2, they're the same thing. And I already checked it algebraically, so I don't need to do that. Okay, now stop the video and go ahead and play around with the algebra tiles and see what you can do, and then do it algebraically. Do the next page. Oh, I guess you need the, if you don't have the notes, you need to see the questions. So here you go. 6n plus 9, doing it both ways, and 6c plus 4c squared. Okay, here are your answers. I'm not going to walk through how to get them because it's kind of right there on the screen. The algebra tiles, it's really a matter of just playing around with it until you get something that makes sense. And the GUKF is fairly straightforward. If you're having trouble with it, I'm happy to help you in class on Monday. Okay, so there's question C. There is question D. Oh, you might not see it on your screen. It says 2C right here. That might not have gotten captured in the video. Okay, on to the next part, which is factoring trinomials. So a trinomial means there are 3 terms. So using algebra tiles for this, this is going to take a while to draw out, so I'm actually going to pause the video. But when you're factoring trinomials, you don't make a rectangle, you make puddles. So I'm going to take, I think the best way to do this is to take the 6 ones and make 6 puddles with ones. So 1, 2, 3, 4, 5, 6. And maybe I won't be able to fill up my 6 puddles, but I'm going to start with 6 because it looks like I probably can. And then and then if I need to combine them again to make it work, I can do that. And then I have minus 12 z's, so I need 12 negative squares, negative z's. So there's 1, 2, so I'm going to put 1 in each. And then I will have enough to actually put 2 in each. And I'm sorry that my coloring in is so lame, but if I do anything else, it'll just disappear on me. Okay, And then I have 18 z squareds, which is going to be, oh, I'm going to be able to put 3 in each pile. So there's 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so what I get is that this equals 6 times 1 minus 2z plus 3z squared. Right, because I have each of my puddles is 1 minus 2z plus 3z squared, and I have 6 puddles, so that's what multiplication means, right? Okay, and then I can do this algebraically using the greatest common factor. So I can go 6 minus 12z plus 18z squared. I can do it the same way. Looking at that, I can see that 6 is the greatest common factor to come out of that. So 6. 6 divided by 6 is 1. Minus 12z divided by 6 is minus 2z. And 18z squared divided by 6 is plus 3z squared, which, ta-da, is what I got when I did it the other way. And then I can also check this one algebraically as well. 6 times 1 minus 2z plus 3z squared. Get my rainbow lines. Do, 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 do. So this equals 6 minus 12z plus 18z squared. And again, please do check your answers by multiplying it out or expanding it. It's just so easy, so fast, and it will catch errors. Okay? All right, it's your turn. I'm going to give you there's the trinomial for you to factor. 5 minus 10z minus 5z squared. So stop the video, factor that, and then check your answer. Come back and check your answer. And there are your answers for factoring trinomials. Okay. A couple things that I would like to point out. One is that when it asks you to factor it, you really should write it out as factors like that. That is actually your answer. Make sure that at the very least this part is highlighted as your answer. Okay? This is your check, and you should do it, but make sure I can find your answer. Okay, because that last line there is not your answer. Okay, last section, factoring polynomials with more than one variable. So you need to factor this really ugly looking polynomial or trinomial. Now, I'm not even going to try and do this with algebra tiles. Yuck. We do the algebra tiles because just to get you to realize that this is really the same as multiplying numbers. It's all using the same techniques. It's just the numbers are a little weirder. So to factor this, I'm going to do it with my little birthday cake. C to the 4d minus 30c cubed d squared minus 25cd. I'm going to do this. Okay, so I'm looking for a number. What number goes into all of those? I'm going to say -5. I could actually do this in stages. Why don't I do it that way? You do want to take out the negative. Okay, so -5 is, that's going to leave me with 4 c to the 4d plus minus 30 divided by -5 is 6 c cubed d squared, and then -25 divided by -5 is +5 cd. And then let's look at the c's. There's only one c in here, so I can only take one c out. So that becomes 4c cubed d plus 3c squared d squared plus 5d. And then let's look at the d's. Again, the smallest is 1, so I can only take out a d. So that is 4c cubed plus 3c squared d plus 5. Okay, so I'm going to write this out as my factoring equals, because I don't have room to write the whole thing out, but I'm actually going to need to multiply these three together. Okay, just like I would, these are all, like, these are the prime factors, you could say, right? Negative 5 and c and d are the prime factors, but I need to multiply them all together to fully factor this. So this becomes negative 5cd times 4c cubed plus 3c squared d plus 5. Okay, and then just to show you that it works, we're going to multiply it back out again. We're going to do the rainbow lines. So negative 5cd times 4c is negative 20c cubed d, and then negative 5 times negative 3, sorry, how did that get to be a 3? Chocolate! Sorry. This is a 6. I don't know where the 3 came from. I'll put it in red. That's a 6. That's a 6. Ooh, can I pretend I did that on purpose because that was me catching an error? Did you see that? Because negative 5 times 3, which I was trying to do here, is negative 15, which is not what I needed to get. Found my error. Yes, we're going to pretend I did that on purpose. All right, but it's fixed now, and this is a 6. So negative 5 times positive 6 is negative 30. C times c squared is c cubed, and d times d is d squared. And then negative 5 times positive 5 is negative 25, and c and d, which is what I started with, so yay. Okay, but remember, this is actually the answer. Okay, so make sure the answer is what's highlighted. Okay, your turn. This is the last thing for you to do. So it's negative 12x cubed y minus 20xy squared minus 16x squared y squared. Stop the video, go ahead and do that. Okay, so the answer to this is, in yellow there, negative 4xy times, in brackets, 3x squared plus 5y plus 4xy. And hopefully you can follow what I did and how I checked it. That's it. That's it for the notes. See you in class on Monday. Bye for now.